All right, welcome to class today. We're in week 5. And today we're going to basically start making the connection between Python and ArcGIS. But before we do that, we're just going to do a little bit of a review of what we've learned so far. Yeah. Yes, I am recording it.
All right, thank you.
Yeah. Now, my earlier class I teach today, my computer actually froze up in the middle of the lecture, and so it didn't record most of class. So hopefully that doesn't happen. But things like that do happen. But I am recording it right now, and I'll try to stop partway through because I do think that helps it. So I probably should have done that. In my earlier class, I don't have like a nice break, but anyway, so we are talking about Python in this course and why we're doing it. Okay, we're doing it because ultimately it will help us to automate GIS tasks, to make GIS tasks go faster. So we've spent 4 weeks before today just learning the Python language. I did try to make a lot of our examples spatial, at least in some way, you know, looking at distance, calculating distances, and those are things that you might have to do in a GIS program. So they'll be useful. But we started off a few weeks ago talking about data types and variables. So, what is a data type? Those are examples of a data type, right? And every thing that we tell the program that we want to hold on to this value for us, okay? That's what we're going to do. Those all have a data type associated with them. So often in programming, it's very useful to have the computer hold on to some number or some string, something for us. Also, sometimes we're going to get those back as a result of functions. We're going to get values back as a result of functions. And those are going to have a data type. Anyway, these entities that have data types are called variables. And Python's kind of it doesn't force us to declare these variables like other programming languages, if you've learned before. Oftentimes, the first time we use the variable, we're implicitly declaring it or giving it a name at that point. So even in a for statement where we say, for x equals range 5 to 10, we've created a variable called x at that point. And x, each time through the loop, is going to hold a different value. So data types and variables. Now we talked a little bit about program flow. Program flow is how you write your program and how you organize your code. Lots of times in programming, you'll find that you'll be repeating a task multiple times, and sometimes you just like to organize your code. When you encounter either of those two types of things that you'd like to do, it's often helpful to write a function. A function can help us compartmentalize code, and a function can help us to have one set of code that does the same thing that we do over and over and over again. And in fact, well, I'll hold on to that until I get down below. Okay. So then we talked about a number of concepts. We talked about making decisions by testing conditions and branching. So we talked about if-then statements. And we talked about Boolean operations. So any if-then statement is basically testing if something's true or not true. we talked about nested if-then statements, so we can branch and have different code run if a certain criteria is true. These are basically the ways that we can create a logical process to our program flow. So if there's any logic that has to go into the problem that we're trying to solve, it's implemented through if-then statements. And we talked about looping. Sometimes it's very useful to do things over and over and over again. That's what looping is all about. We did talk about functions. I already talked about functions up when I talked about program flow. But I'll say one more thing about functions, is that functions have inputs and they have outputs. So the inputs are sometimes called arguments or parameters, and the outputs are the result. And the output will be a variable that we can assign. I think in a lot of the questions I've had up to this point, people, it seems like a lot of the students in this class are still struggling with the concept that I can set a function equal to a variable, and then I get to store the result of the function in the variable. But in order to do that, I had to have a return statement in my function somewhere. So it's a way to feed something into a function, run it, and get something out. Now, that also brings into consideration something that's global or something that's local. Anything that's declared inside the function. And remember, Python doesn't explicitly declare anything, but if you said something like x equals 5 inside the function, if you're inside the function, in Python that means if you're indented, and that's the first time you used x and you said x equals 5, then x is only inside that function. Once the function runs, it doesn't exist anymore. And when it runs again, x will equal 5 again, and it'll only be inside that function. That's the concept of something being local versus something being global. All right, so now on to a few things that we haven't really discussed up to this point. So we have what we call methods and properties, which we kind of have discussed. Oh, sorry, classes and objects and methods and properties. Today, when we start using ArcGIS, we start interacting with ArcGIS, we're going to be consuming things called classes and objects a lot more. We've done a little bit of this up to this point, but we haven't done. Let's see what this one does. Nope, this is all. I was going to see if I had a previous example of a class. There is some in your book. I probably should have just shown those in the book. In the book. Oh, I think I have an example from a previous year, because I had you program that. I mean, I had the students program something, but it really isn't necessary for this class to be programming our own classes and objects. No, maybe it was 2015. I abandoned it. Yeah, here we go. So I'm just going to. This is a 2015 example 4.py. So you create a class really similar to the way that you create a function. Okay, except for you use this keyword class instead of def. And a class is a description of a generic type of thing. Okay? So a class could be, let's think about this more abstractly, but a class could represent a person. Okay? So that person would have attributes, and it could have things that it does. We would call the attributes, we would call those attributes properties. And the things that it does, we would call methods. So in this class called a point, it has two properties that we set up. So this function runs whenever you create a new object of class point. So that's how objects and classes are related. Objects are things of a particular class. Okay, so all objects that are points have an x and a y. All objects that are this type of point that I'm creating this object. Now ArcGIS already has its own point class in it. We don't have to create classes very often, particularly for what we're doing. Okay, but I'm just showing you this code here because it illustrates this point of what a class is and what an object is. I'll open this up in IDLE. So I actually taught this in a different. I slowed the class down a little bit this time. Okay, C temp. No, CS. C temp. SPA. Week 5. I'm going to call this 2018 example 1. Oops. I meant to say file new. File, new file. Oops. Save. C temp SPA 5 2018. So here we create a class, and this is called the initialize. Usually in Python, this is just something for you to know. In Python, when there's two underscores, the name of a function and two other underscores, it's an internal function that's not meant to ever be used or called directly. This function gets called when you create a new point by saying my point is equal to point. Okay? So this function gets called when that happens. So later today, when we start dealing with ArcGIS objects and classes, when we create a new entity, a new object, know in the background that there's an initialize function that's running in the background. Okay? It's setting up some initial parameters. So what are the default values for x and y that get created when I create my new point? They're the only numbers on that page. Yeah, 0 and 0. Okay? So those get put into the x and the y value. So right here, when I print my point, I'm going to get, when I print my point x, I'm going to get a value of 0. So I'm going to run this, and that's why I get a value of 0, the first value of 0. So, when when I run this function called shift x, it's going to shift. It's going to basically take the current x value and it's going to shift it by 10. Okay? And then I can print that value. I can move it over. Another way to describe shifting is called translate, right? In fact, I could write another function really quickly to do the same thing. And I could just call it translate. And then I could say x shift and y shift. And then so now I have another method inside of my class. So that would allow people that use this class to translate it by a certain x and y. I could optionally have another function that allows me to specify an angle and a distance, and then I have to do a bunch of math, but I could still move that point by that amount. I won't do that math, but that would involve some trigonometry to figure out that distance. Okay? To figure out the new x and the new y. Oh, yep. We'll change that to y. So this will work. So these are properties, and these are methods of this class. So when an object is created of this class, it always has these properties and those methods that we can change. So that is a class. So the reason why when I run this module, if I shift it once, I get to 10, and I shift it again, I get to 20. See, I called it, I shifted it once to 10, and I printed X, and then I shifted it again, another 10, and I printed it again, and I get 20. So I'm moving it over again. If I had a class called people, I might say grow, and then give a certain amount, and it would grow in terms of height, and it would change their height property each time. So that's how I could utilize that. So that's classes and objects. And like I said, for this class, we're not going to be creating our own classes and objects as much as we are going to be consumers of classes and objects. So sometimes when you get a variable, it will be of a certain class, and so you'll need to know what that variable's properties and methods are. And oftentimes there's documentation. As I said, ArcGIS has its own built-in point class. So later we'll talk about, we're not gonna actually get into individual points today. Today we're gonna just get into ArcGIS in general and doing ArcGIS commands like overlay. But what if we did want to get out the individual points? That is something that we might want to do. Okay? Well, this is the method for creating a new point. Okay? And these are the different properties of a point. A point has an X, a Y, a Z. We all know what those are. Points also have an ID property and an M property. An ID kind of makes sense. What's the M value? Well, the M value is just some other value that could be stored there. Now look at all these methods. You can ask if a point contains another point. In other words, are they the same point? You can clone a point, so that's a method. A method of a point is to clone, and it will produce a brand new point at the same exact point. Anyway, there's a bunch of different methods that they've built into ArcGIS. You can ask if it touches a line or a polygon. So they've built all these into ArcGIS, and these are just classes that they built here in Python. So they built one called def touches, and then they said self. You always have to, when you build it inside of a class, you refer to the self is the object itself, and then other geometry was the other thing that it gave it. And then finally you would just write the code to find out if, yeah.
When you talk about declaring variable self within a function, you said we need to do that. Is that because that's proper Python syntax or just good programming practice when you do that?
No, in Python, when you build your own class, you do have to feed it manually the self. That's not just proper Python syntax. But it's only if you're building a class, your own class. So this is the internal to the class code. But the internal to the class code, you need this self keyword.
Okay, so self is a reserved word?
Yes. Yeah, self is this point. So once your point gets created, if you want to reference the point that is this point, you need a way to do it. And Python forces you to make it explicit. So there probably are other computer programming languages where you don't need to write self or anything, but Python forces you to explicitly pass in this entity if you want to control that entity.
Okay.
So self is the object that was created. So self will be different for every object of that class. That's why it's kind of a general word that you use. Okay. I'm not actually going to write the code that would do this. It's rather complicated, and that's one reason why ArcGIS, I mean, not extremely complicated, but that's one reason why ArcGIS, why people pay for ArcGIS is that it has already written a lot of this code that does GIS type things, and one of those things is, does this geometry touch this geometry? If so, do something. So that's why that exists. And so that brings us to the next topic here, a module. A module is a group of code that that does something for you, and it may contain, and it usually does contain, some functions and some constants, like the math module contains the constant pi, and the math module contains a function called square root. But on top of that, a module might contain classes. Like the ArcPy module contains this class called point. It contains it, and you can create a new point using that syntax, ArcPy.point. So that module contains that this object, or this class, and I create it, and now I have the result there. Okay. Now I had that. So this, just to be clear, sorry, I shouldn't have. Just to be clear, this ArcPy.point is a class. This is how I create it. So this is going to run the init function, the underscore int, and it's going to feed the result into point, which is going to be a brand new point. Now in this case, the point's going to have these coordinates. That's what that means.
Is that for any unit of measurement, or is there only one type of unit of measurement?
I don't know what you. Oh, you mean like meters, feet, right? Is that what you mean?
Yes, sir.
Yeah. So there's a. There is a thing called a point geometry, which is above a point, and point geometries do have a spatial reference associated with them. So a point geometry contains a point, but it also has a spatial reference. So a point itself doesn't need a spatial reference because you could just say, well, it's in whatever I want it to be. But if you do want to store a spatial reference, you can use a point geometry. So you can create a point, and then the way you create a point geometry, and we're going to get into this in a couple of weeks. The way you create a point geometry is you give it your point, and then you give it a spatial reference, which is optional. And then you also give it a true statement for if it has a z-value or if it doesn't have an n-value. So it requires a point. Optionally, you can give it a spatial reference. And just to get back to your question, a spatial reference does contain not only projection information, but it needs to contain the units as well. So the units will be stored there in the spatial reference. So that's the way that ArcGIS has it set up. There's a point geometry. So modules are just a group of code that very likely, particularly for more complex entities like ArcPy, that contain functions, some constants, and they can contain some classes. That's why I went over classes. Now your book actually talks about it, but from now on we're kind of departing from the book. So you could go through that chapter and write your own classes, but we're not going to cover that for this class. Okay? Class. All right. So they're kind of like functions, but they're bigger than functions because they can contain classes which can be used to create objects, and objects can themselves contain multiple functions. So they're just ways to organize your code better. So if you did find that you could organize your code better, which for this course, our code's not going to get that complicated. But if you did want to write something like that, you could use classes and objects to organize your code better. So we have already been using these, whether we know it or not. So we already talked about this up here, but now, what is a class and what is an object? So everybody understand? Somebody answer this question. What's the difference between a class and an object?
The class is the way you have to create the object, and the object is...
Yeah, the object is the actual entity. Sometimes people say an object is an instance of a class. So an object is an instance of a class. So a class is almost like a data type, and an object is a variable that you've stored it. So in Python, where basically everything is actually even functions themselves can be assigned as a variable. Basically, what that does is make every variable is really an object. Some of them are very simple objects that only have one property, but some of them are complex and they have multiple methods and multiple properties associated with them. So you usually create a class the same way. We talked about how you create a class. You usually create an object the same way you create a variable, using syntax like this. Go back to the page like this, where you usually set something equal to the name of the class and then whatever function you need to do to create it. So in this case, we need to feed it an x and a y. A class gets created using this class keyword. All right, so I did already say things like this, but again, this class will mostly be consumers of classes and objects. Others have written ESRI, some of the just programmers of Python. But if it helps you to organize things, go ahead and create your own. But we're not going to cover those chapters in the book. This constitutes all the portion of the class where we talk about creating objects and classes. Well, we're still going to talk about creating objects because we're going to create objects from classes, but those classes are already written. We're not going to create our own classes. Okay? All right. So now we're going to talk about ArcPy because ArcPy is a module kind of like the math module, but a lot more complex, that ArcGIS installs along with ArcGIS. And it's done that since version 10. Prior to version 10, you had to actually choose to install it. But they integrated it so tightly with ArcGIS that now it installs as part of ArcGIS. And some of the tools don't actually even run without it because they've written the tools in Python themselves. Okay? It's a Python module. And it has Python built right in. And you can access this module through the IDLE, but you can also access the Python module right through the ArcGIS interface. So this is ArcMap. Organize things a little bit better here. And if I go to geoprocessing, there's a window called Python. And I can access ArcGIS right. I can access ArcPy right from this window. Okay? I can type a Python command. In fact, I could type in that ArcPy.point 4,5 and say my point equals, press enter. Has no attribute point. Does it have a capital P? I just looked at the help. Yep. So you still gotta type in your syntax, right? There we go. It does help. There it is right there. It does provide you help inside of ArcGIS. So now I've created my point. I can print it. Of course, it might not be very descriptive. Oh, it does. It prints out 4 or 5. But interestingly, that means that inside of the class definition, they've written a print command. They've written a way that it should be printed. So 4 or 5, not a number, because I didn't give it a Z or an M value. So that doesn't seem very useful. We could use it to do something on the map with the map data. Okay. So this is one of the 2 data sets. This is actually the lab data. We've got watersheds and sea tracks. So watershed stands for watershed. What's a watershed?
Water network.
Yeah. So watersheds are typically defined by a point, and they represent all the upslope area of that point. Okay. Now these watersheds are really subbasins. So in reality, this watershed flows into this watershed. But these are U.S. government watersheds, and they've decided that once a watershed gets so big, we'll divide it. So really, this watershed here is this watershed, and the upslope area probably includes this and this area. Whereas this watershed is the Pearl River watershed, so all of the water here is just flowing out into the Gulf of Mexico. This is Pearl River. This is kind of an amalgamation of a bunch of little watersheds, because usually in coastal areas, there'll be a lot of little watersheds, and then there'll be one that drains a huge area like this. This is just a coastal watershed. If we went over like 3 or 4 watersheds this way, the watershed would drain, most of North America, Mississippi. Anyway, so those are watersheds, and these are census tracts. What are census tracts again? Census tracts are designed to be about the same size in terms of the amount of people that live in them, not in terms of the size. So you see that in areas like here, you get a lot smaller census tracts. There's areas here. And they really don't like to change the size of census tracts over time, so if they do divide them, they usually divide them within the same. So if you combine them back up, they'd be the exact same size. So I don't have to redraw the boundaries. But they're from the census. So if I click on any of these guys, I can get the information, of course. How come it doesn't? I'm just going to have to open up the attribute table. So I'll just look at that one. So I can see the population. I don't know what year this was. I'm not sure. But that's the only attribute I have is the population, which is that value. Variable right there. 5,668 people. There's a few other information, but none of it's really pertinent. So that's the information. All right. Okay. I want to clear the selection. There we go. Clear the selection. Okay. So I can do things that you would normally do. Like what's something that, well, I'll just provide an example. Okay. What does a buffer do inside of ArcGIS? Right. Now, let me get the other data set real quick. So I'm going to go to the other data set's called Ty-Dixon Park Tutorial Data. And I'm just going to get this data and put it in CTEMP2.
Is the Dixon Park tutorial data part of lab data?
No, it's on the M4 data, but like if you go to the website, it should be, unless it didn't upload. Yeah. Ty-Dixon Park Tutorial Data. I'm going to get this because there's some points and lines and polygons rather than just polygons. And I'm just going to hit new blank map and add the Ty-Dixon data because it's a little bit, we'll deal with the lab data in a second here, but this has a lot more, a different variety of data. So this is that's not what I meant to do. I'm just going to add everything except for this sample intensity table. Okay, so this is some data of a watershed in Jamaica, and I'm going to buffer all those lines. This is a single watershed. I'm going to buffer all those lines. Okay, and you might be asking, why are we doing this in Python? Well, we're doing this in Python so we can learn how to automate it later. That's why the identify didn't work, because the thing was way off the screen. I'm showing an example of how in Python you can buffer something. So any tool that's available in Toolbox, you can get to by saying arcpy dot, and then sometimes you have to find out what the tool is called in Python, but it's almost always very, very similar. And then it'll have an underscore with the name of the toolbox that it's in. So I'm going to search for buffer, and you'll notice that there are actually 3 different buffer tools. There's the buffer 3D, which is in 3D Analyst, which will do a 3-dimensional buffer, which is not usually what we want. So it'll buffer it this way and this way. But when we're talking about planimetric data like this, we only want to buffer it normally. That's the buffer analysis. The buffer arc, anybody know what that one is? It's a good guess. No, it's under the arc, the coverage tools, and so an ArcGIS coverage is an older format that only allowed topologically correct data. And so when you buffer 2 points, it would buffer them together, and they would form like a MasterCard symbol if they were just barely not touching. And that would be one polygon that made a MasterCard symbol. That's the only thing you could get. I don't know why I'm calling it MasterCard. That's what it looks like. But buffer analysis works on any data type, and what it'll give you is two overlapping circles, and you can decide whether you want them to be pushed together to form one polygon or not. So I'm going to choose that one. Buffer analysis is the one that we run more often today. Okay. And then if I press, this is a function, arcpy.buffer. So inside the arcpy module, there's a function. This isn't a class. This is a function. This function called buffer analysis, if I put a parenthesis, that's how I say I want to run the function. Now look at all of these things, or sorry, you look over here. These are all of the parameters that need to go into this function. Anybody ever run buffer before? Who's run buffer before inside of ArcGIS? Everybody, right? We all run buffer. Okay? So here's a description of all of these parameters, because there are 1, 2, 3, 4, 5, 6, 7, 8 things that we need to put in here. Okay? With typical tools, not the raster tools. We'll talk about raster tools later. But with all the other tools in ArcGIS, typically all of your inputs are just strings. Okay? So you're going to feed it. These are all going to be strings. Buffer distance. Now you could feed it a number too, and ArcGIS is actually smart enough, or inside the functions that they've written, they've actually said, okay, if it's a number, just convert it to a string, or if it's a string, convert it to a number, or whatnot. Okay, so let's look. These are the descriptions right here. So the first one is the feature layer. What do you think that one is? Well, it describes it right there, right? The input point liner polygon feature to buffer. I'm going to buffer. For now, I said I wanted to buffer oh, I thought I had a rivers layer. I guess those aren't rivers, those are roads. So we're going to buffer the roads. Risk. Oh, I got to put it in quotes. Risk underscore road. So now it's going to buffer the roads. Now when I press comma, it's going to know to move on to the next thing. See the output feature class? All right. Now that output feature class needs to be somewhere on disk. So you need to feed it a real location. And remember last week I told you about this little R thing? I always like to do that. So I'm going to say C:/temp/ if you don't have a C:/temp, this isn't going to work for you. You're going to have to come up with another place to save it. But I'm going to call this road buff.shp. So now I'm saving that out to that location. So when I'm done, I should expect to see my output stored in that location. That's where I am right now, the output feature class.
Dr. Raver.
Yeah.
Do you have to specify the output every time, or will it go to whatever, I guess, folder you have in your workspace as your selected output, whether it's your workspace or your Stripe workspace?
Yeah. So yes.
So it will default to your workspace location?
Yeah. If you don't want to type the whole path, it'll default to your workspace location. It will fail, however, if your workspace location is empty. Also, another thing is if your workspace points to a file geodatabase and you put .shp on the end, it will also fail. So there's just a few things that you need to keep in mind there. What is a workspace, by the way? If I go up to here to geoprocessing and I go to environments, I can set the workspace right here. So see how it says default.gdb? That's where it's going to save it right now. Now,
So because the default workspace is geodatabase, if I were to just put in roadbuff.shp, it would fail. right?
I'm pretty sure it will. Let's see here. Let's just do buffer distance. I'm going to say 300. Now, these squiggly brackets actually mean that they're optional. So all the other values are optional. We don't need to put them. See all the rest of them are squiggly? We could talk about what they mean, but this isn't really the class for that. But basically they allow us, in this particular thing, they allow us to buffer on both sides or just one side of a line. Since it's points, it doesn't really matter. They let us decide whether or not we want MasterCard symbols if we're buffering points. Like, that's what this dissolve option does. Where's the dissolve option? It basically, left side full. Oh, sorry, that's actually the, dissolve option. None. Yeah. Do we want no dissolve option? Do we want to dissolve all the buffers? So anytime two buffers touch, do we want to dissolve it, or do we want to leave it as two overlapping circles or two overlapping entities? That's what that is. So you can always go and read all the help here, but everything else is what do you call it? Optional. So I'm just going to close it by hitting a parenthesis. So now I've written Python code that will run a buffer on risk roads and save it as roads_buff.shape. And I said it would fail. I think it will. I'm going to try it. Because it's trying to write it to that. I just hit enter. I tried to just hit enter. Oh, there it goes. Okay, it didn't fail. It did put it in C users documents ArcGIS roadbuff.shape. Is that the? It might be. So it looks like it just. It did save a shapefile, but it looks like it just put it in the same folder as this geodatabase. See what I'm saying? So it looks like it worked just fine, but it put it in the same folder. Now I wonder if I ran it again, if I did say, let's try to run it again, and this time I'm going to not put .shp on there. So it did put that into the geodatabase. Okay? Yeah.
I got an error the first time. It says background server through an exception.
Did you get an error the second time?
I didn't run it again.
Okay. Try running it a second time. Did everybody get an error here, or?
I got an error the second time. This should go in the same.
Now, what is your workspace set to? Same as mine?
It's set to the lab database, like all the lab days in the database.
Okay, and it's set to there.
Yeah, we ran that.
It ran that time, the second time, without the .shp?
No, I didn't know. I left the .shp on. Like, I literally just copied from the first hour.
That's weird.
I'm trying to direct mine to a thumb drive, it's not letting me do that. So try to do it to the hard drive.
Try. It's failing. Are you sure that that path exists?
I did it to my desktop, and then I did it by just named the shapefile, and both of them worked.
Okay. Well, cool.
But it is putting it like one folder up for that geodatabase.
Right. That's what mine did. So I'm showing you how to run it in ArcGIS. Probably the reason that if it's still failing for any of you, it's probably failing because it can't find the path to that location. When you're running this as a script outside of ArcGIS, it's much easier to just be explicit about where you want it to store it, rather than than trying to mess around. And sometimes explicit involves specifying the environment. If you're running it outside of ArcGIS, you can still specify the workspace. You just have to do it programmatically. We'll talk about that in a second. So we've just buffered the roads, and just another little note. Okay, a shapefile is a slightly different thing than a feature class that's in a geodatabase. I don't know if everybody's dealt with that before, but notice that there's some things that ArcGIS does when something is a feature class inside of a geodatabase that it doesn't do when it's a shapefile. So one of those things is that it automatically, if it's in a file geodatabase, it automatically calculates these two fields, the shape length and the shape area. It doesn't do that for a shapefile. Okay, it's just, I think that's the code internal into the file geodatabase. Anything that goes in there, it creates those fields. They're auto-generated fields. These two fields right here. Okay. Other things is that the unique identifier is typically different in a shapefile, not always though, than it is in a file geodatabase. It's called FID here, FID star, I guess. Whenever it's a file geodatabase, it automatically creates shape length and shape area. You can create it like inside of RoadBuff. I could calculate a new field. I could add a field and then calculate geometry into that field. I could do that. It's possible. I can actually even do that in Python. ArcGIS dot ArcPy. Sorry, ArcPy dot calculate maybe there isn't a tool for it. But I'd have to look inside of the Arc Toolbox. So any tool that I know to run, I can look for it in here. Arc, what's that? Yes. So it doesn't look like there's a function for, there's add XY coordinates, but I don't see a function for calculating the geometry. Oh. Calculate areas. Yeah, calculate areas. So calculate areas, yes, calculates the area values for each feature in a feature class, in a polygon feature class. So we could calculate the area. Is there calculate lengths? Is there a calculate lengths? No. Okay. But what Elida said is correct. For any tool that runs in Arc Toolbox, you can go look at the Python syntax for running that tool. Okay. So this tool only requires an input feature class and an output feature class. That's all it requires. And here's, I guess I'll go ahead and talk about this right now. So if we were running this outside of ArcGIS as a standalone script, we still have the opportunity to adjust the workspace, and that's through basically it's a set of values. It's a set of values that are all grouped together called .env. So arcpy.env.workspace, and anything that you can set here under geoprocessing environments. See how there's just tons of stuff you can set here? You can set the workspace. You can set the cell size. You can set the random number seed if you're doing that. You could do the processing extent is actually a pretty big one, right? Do you want the processing extent to be something different than the default, which the default is going to be the intersection between the two inputs, or 5 inputs, or 6 inputs, however many inputs you have. By default, the processing extent will always be the intersection of them. If you want them to be the union of all the inputs, in other words, as big as the maximum extent of all your inputs, then you could change it to union of inputs, intersection of inputs, and so on. So basically anything you can control, not basically, literally anything that you can control in the environments, you can control in Python by using the env statement. That is, I did mean to talk about that. I guess I'm pretty close. So I've covered using tools in Arc. Oh, I haven't covered importing ArcPy because we've been using it inside of ArcGIS. Okay. So the ArcPy module is for making requests to the ArcGIS toolbox. You can import ArcPy. You can use tools, and then this environmental object. So the ArcPy.env allows you to set or change default processing options for geoprocessing. These are some that are very popular. Cell size, extent, and overwrite output is a big one. Okay. Overwrite output by default is set to false. So if you're writing a script where you are running the same script every day, and the script is like doing an intersect between two different data sets that are created brand new every day, and it's writing over the old data set, you'll need to remember to set overwrite output equal to true. Or even more often is the case, what if I've given you an assignment, like you're going to get an assignment today, and you're going to try to create an output. The second time you run your script, it's going to fail because the overwrite output isn't set to true. So you need to make sure you set your overwrite output to true, and it will then work. But not all the time. Okay, so something that is really a big stumbling block for people programming in ArcGIS a lot is that in Python is that if the file is open in ArcGIS, even if overwrite output is true, it won't let you see it. It won't let you overwrite it. And so sometimes you'll be trying to run a thing and it'll just keep failing. Why can't I run this? And it's failing like when it's trying to output it. It's because it'll say something like, cannot get an exclusive schema lock. And if that's the case, it's because it's open. And sometimes ArcGIS is really frustrating with how much with how much it's locked. Sometimes you actually have to close ArcGIS to get it to run in the program outside of ArcGIS. So I'm going to try to run this guy one more time inside of ArcGIS. I'm going to just try to copy and paste this and try to run it again. And it's going to work for me. It may not work for everybody. The reason that it works is because under geoprocessing options, I've said overwrite the outputs of geoprocessing operations. So if I uncheck that and say OK, it should fail. See how it fails? Okay, it already exists. So if you're coding this outside of ArcGIS, you need to have a way to manually tick that box, the overwrite outputs box. So now it'll work again because I ticked it. All right, let's practice doing that outside of ArcGIS. So I'm going to open up IDLE. So my code's going to have to be a little bit longer because the first thing outside of ArcGIS, if you're running your script outside of ArcGIS, the first thing you have to do is import ArcPy. Now when you do that, as soon as you hit import ArcPy, and you run this code, it's as if you're actually using an ArcGIS license at that point. And so if your machine is using a pool of licenses, like both on this campus and on the coast are using, your machine is running a separate license when it runs this. It's like a separate entity of ArcGIS. And also, what this implies is, even if you went and installed Python, if you tried to write import ArcPy, it wouldn't work because you're not licensed for ArcGIS. If your license expires, it's going to fail on this line of code. It's not going to run it. So import ArcPy is starting up ArcGIS. Yes?
Are we talking about where we're about to import, so we're going to write text outside of ArcMap and import it into Arc, or vice versa?
Well, I'm just showing you how you could, because oftentimes you want to write a big script that does something, and you don't necessarily want to open ArcGIS to do it each time. And so this scenario right here is if you wanted to write a program that you could just run, you could have it set up to run on a daily basis, so that it would do something. There's a reason that you'd want to have a script that would execute outside of ArcGIS. That's all I'm trying to say. So this is the way you get to run ArcPy outside of ArcGIS. Also, you can't build a script in this interface. So Python here inside of ArcGIS only has an interpreter window. It's not scripted. So you can actually feed it multiple commands. Like, I'm pretty sure this will work. Let's see. Although it's been a little while since I did this, I'm going to open up Notepad. Like, let's just say I wanted to buffer this, 5 times, and I wanted to do like this. And then I'm just going to call this 3, 4, 5, 6, 7. I'm pretty sure I can feed it all of these. Yes. So I just copied in 4 commands, and I cut and pasted them into the interpreter window, and I could run them. So you still can't do scripting, but you could run multiple commands in the command window. And now I just created a buffer 4 times. So here's 7. There's a little bit smaller 6, a little bit smaller 5, 4, 3, 2, and so on. Okay. So in a pinch, if you just wanted to, if you were trying to run the same command a bunch of times and you knew it was going to take like 15 minutes for each process to run, you could queue them up like that and go get a drink and come back, right? Okay. But let's say you wanted to write a full script with like logic included in it, then it would be much better to write it in Python like this. I'm going to go ahead and save this as C temp M5, no, SPA M5 2018 example 2. So if you're going to run it outside of ArcGIS, you need to import ArcPy. That's like starting up ArcGIS. Then the next thing that you need to do is let me make sure this is still going. Looks like it. The next thing that you need to do is set up any environments that you want to run. So we could go ArcPy dot, And we've got env dot, let's set the workspace equal to, I'm going to set it equal to the same, this one, because why not? So now we've set that equal to that. And we need to say arcpy dot, well, let's just leave that blank for now. Okay? I was gonna set override outputs. So I'm gonna try to run it first. Oh. What data type is this right here? What do I want that data type to be? Yeah, it's a string. So what do I need to do to actually make it a string? You put quotation marks around it. And anytime there's slashes, I've already said I like to put the little r in front of it, because I always forget which slashes are which, and that way my code will run better. Okay, now I can do arcpy dot buffer underscore analysis. One thing that I like to do actually when I'm coding is have ArcGIS open and go to the tool that I'm thinking of using, which is under proximity buffer, and go to tool help, and then just look at the syntax here and just copy and paste. So here is the syntax here. Okay. There's the syntax, buffer analysis. Here's an example of the syntax being used. So I'm just going to copy this line. Oops, that's way more than a line. I'm just going to go ahead and copy that line in there into Python. That's easier. So now I've got that line. I don't really care about the dissolve field, the dissolve type, the end type, the side type. Okay. So I'm gonna say what's my. I'm gonna do it like they did. So if I say roads is equal to, I need to feed it the. Now instead I don't have the access to this roads layer. See my roads layer? Where is risk roads? I don't have access to that layer. I can't just call it risk roads. I have to actually get the entire path to risk roads. If I go to source, there's the entire path. Now, if this was in the same directory as this, if it was in the same workspace, I would be all set. But it's not, so I have to do that. If risk roads was in here, I could just put quote unquote risk roads. I could, but if I'm going to write to that directory, yeah. So you're right. I could do this. I could do that, right? And then I could do this.
What was her question, Dr. Evans?
Oh, sorry. Her question was, why couldn't I just make the workspace that so that I could access this? But now, when I assign the roads buffer, if I want to save it, if I want to save the roads buffer out to that other folder, then I need to enter the whole path. I only get one workspace. So this will work, though, if I just put it into the same folder that I have the input. And lots of times, that's what you're doing. You're just writing to the same folder as the input. So now if I said risk roads buff, then I'll be all set. I'm going to look at the risk roads. I do think there's a buffer field on there. Yeah, this terrestrial distance is a buffer field. TERR_dista. Yeah. Okay, so what is this? What is this TERR dista? What is that? That's a field, right? Okay, how does buffer work? Usually buffer takes a distance, but what if I feed it the name of a field? What's it going to do? Anybody know? Let's look at what the description is. So let's look down here. So the third, 1, 2, 3. This is buffer, distance, or field. So read that description in your head, and then tell me what it's going to do different than just using a number.
It's gonna just buffer around the area that's good terrain. Like, it's just gonna wash it.
That's not really good.
That field,
It's taking the field.
that's a limit. Of that, like the distance of the layer on this layer that you're using as a field.
I think you're saying it now. So if I go back to here, and this is more of a GIS type, this isn't really Python, but see this field? So this road is going to get buffered by 30, whereas this road is going to get buffered by 60. It uses the values of the field to make the buffer. That's what it's doing. Okay. So again, I think on the first day, I said that once we start talking about GIS, there's going to be just as much questions about how do I do this GIS than there is going to be how do I do this in Python. Because that Python stuff's actually going to be, it's all mostly downhill from here in terms of the complexity of the Python. Because we're just going to be calling these ArcGIS commands. We're going to get a little bit more complex over the next few weeks. We're actually going to talk about what if I wanted to find all the points along this line and do something with them. But anyway, I'm going off track a little bit. So, yeah. The hard part sometimes is figuring out how to do it in ArcGIS. If you can figure out how you can do it in ArcGIS, lots of times it's pretty easy to get into Python. You just need to figure out what tools to run inside of Python to do your problem. So for today's lab, that's what we're going to do. We're going to discuss together how to do it outside of Python, all the steps you need to do, write down all the steps you do, and then you're just going to run them in Python. And you just need to remember that when you run one tool, the path of the output to one tool needs to be the path for the input to the next tool to chain your tools together. Okay? So we'll practice that a little bit too. But anyway, yeah, this column right here means that. So let's go ahead and run this at this point. And it's pretty simple script. It actually only calls one function right here. We're just setting up some variables here. We could have just put these values right into here. I just did it a little bit different. So these values could have gone right into there. So I'm going to try to run this. Okay. Well, they're going to have, if the numbers are the same, the buffer will be the same size. So it didn't do anything because I didn't print anything. I mean, it didn't like say, I'm done, right? Now it doesn't show up in ArcGIS. I'm going to try to run my script again to see if it fails or not. It failed. Now look what it said here. Parameters are not valid. That's not very descriptive. But it does say right here, feature class blah 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 already exists. Failed to execute. So it didn't run, even though I have the environment checked inside of ArcGIS, it didn't carry that over. I have to set up the workspace parameters I want in here too. So that's why I need to say arcpy dot, I don't think it's actually an environmental parameter. Let me see. I'm just going to search for it. ArcGIS, arc, I'm just going to say arcpy, overwrite, output. Just make sure I spell everything right. It might be an environmental parameter, I just forgot. Yes, arcpy.env.overwrite output. So I need to put that right here. And I need to say equals true. So now it will overwrite it. If I run this again, it will not give me all the red text. It'll just pop up here in a second and it'll show the three pairs with their wrong. So see, it ran. I didn't have a print statement, but it ran. So those are some of the pitfalls. Now, what if I want to look at it? Well, I bring it into ArcGIS like this. Now it's right, it should be in there. See, risk, roads, buff. That's the one I just created, right? Open that. I'm just going to create those two. So these are the roads and the roads buffer. See how this road is buffered less than this road? Buffered less. This is buffered 60 and that's buffered 30. So we're not always going to teach all the GIS concepts, but that's what that parameter did. If you want to dynamically buffer things differently. All right, now watch this. If I try to run this again, it's going to fail. And this is what I was talking about. If you leave it open inside of ArcGIS, it doesn't work. See how it says risk roads buff dot shape already exists. Oh no. I thought this is the exact same command. I thought that I said override output is okay. Sorry, the exact same error. This and this are the exact same error. Why isn't it working? It's not working because if it's open somewhere, it also won't let me override it. Now let's hope, sometimes, this is where it gets really frustrating to me. Sometimes it lets you override it, and sometimes you have to shut ArcGIS down all the way before you rerun it. Okay, it looks like it worked. Yeah. Yep, it did work, by the way. Okay, yep, this is the code window.
Thank you.
Then it'll always work. But that gets frustrating to keep changing the name. But yeah, it'll always work to just keep changing the output name. Buffer one, but so not that I haven't done that before, you know. Sometimes I'll just after a while I'll start calling it thing 1, thing 2, thing 3, thing 4, just to have it run multiple times. Okay, just as another example here, this buffer. So which one is the dissolve option? That is 1, 2, 3. ArcGIS does allow you to just enter nothing. If it's optional, you can enter nothing. So here's the dissolve option, and I want this to be all. See how this is the dissolve option, all? All buffers are dissolved together into a single feature, removing any overlap. So I'm going to run this guy just to show you the difference between that one. I think it's done running. So I'm going to try to add it. See how that's different? See there's no more lines between the features that were buffered. We could have gotten the same thing by running buffer first, then dissolve. Okay, but it's just an option so that it does it all in one step. So that's that. Now you can see these are still bigger buffers than these, but they've been fused together, so they're all the same buffer. Which is often more often what you want. If you're trying to ask what's the total area that's within the buffer from the road, you would ask this polygon. Because if you ask the other polygon, anywhere where it overlapped, you'd be getting double counted. You'd be double counting. You wouldn't want that. So just remember that when you do. Yeah.
So you were talking about the MasterCard symbol. That's pretty easy description, I hope. So if you use the dissolve tool on 2 points that form a MasterCard symbol, are you going to merge those or get rid of it completely?
So when it's all, it's going to merge them.
Okay.
And then when it is none, that's the default, and it's not going to merge anything. Okay? So if they overlap and they're from two different features, you're going to get two overlapping. If they're 2 points, you're going to get two overlapping circles. If they're roads, you're going to get different shapes. So that's done. That's the default. The default is to make overlapping shapes. All means that everything is going to get dissolved no matter what. List, if you wrote list, then you'd also have to give it a list of fields. And if you did list of fields, if any of those fields share the same attribute, then it will dissolve it. If they don't, it won't dissolve it. And again, if you, here's where you give the list of fields. You could, any of these three, you could accomplish by also doing the dissolve setting. Well, actually, you do this one. Either of these two, you could accomplish by running dissolve as a separate tool. Okay, just run the dissolve tool. Yeah. Yeah, so the question this time was, what if I'm looping and I want to output something different each time through the loop? Is that the question?
Yeah, like say you want to do like 5 different buffers, 10 meters, 20.
Yeah, exactly. Yeah, well, let's do that right now. But the best way to do that would be to do something in the loop that you could change the name of it. Okay, so what I'm going to do here, I'm going to save this as a new example. Save as, because that is, what you're describing, Elida, is something that happens a lot and that you'd want to do scripting in a scripting manner. Okay, so I've got my roads buffer. I'm going to change this so that it's just that. And then I'm going to say yeah. Sorry, what was the question?
You saved it for that example to stay there, but I don't think you changed the name on this one. Example 3.
Did I already do example 3? I thought the last one was example 2.
Oh, we're on 2.
Yeah. Oh, you mean I didn't save 2? Here, I'll go back and make sure I save 2. I'm going to save this as 2, so we'll have it. Okay. It already exists. I don't know if it was the same or not, but now I'm going to file save as and save this as 3, and then I'm going to start changing this. Okay, so the first thing I did was delete that sheet because we're going to append that later. And then the next thing I'm going to do is say for buffs, or for buffer, actually I'll do for buff distance, that sounds better, for buff distance in range 100, comma, 1000, comma, 100. What's that do, by the way? We only talked about that briefly one class period, but yeah, it increments by 100 And it starts at 100 and goes to 1,000. It goes from 100 to 1,000 by hundreds. So it's the minimum number, the maximum number, and the step.
That way, if you're not like a line, you're getting both sides. Is that what you mean?
No, that's inside the buffer analysis. You can do both lines. But this is just going to create a number each time through the loop. It's going to buff distance is going to equal 100, then 200, 300, 400, 500, 600. It's going to go all the way to 1,000, step by 100. That's all this does. All right. So what I'm going to do is run this buffer analysis. I'm going to run that buffer analysis over and over again. But this Rhodes buffer, the output, is going to now, I'm going to set that equal to the buff distance. Oh, sorry, that doesn't need to be in quotes. Buff distance. So now Rhodes buffer. What is Rhodes buffer? What's stored in this variable? Yeah, that's the file that we output. So what I want to do is make this say risk Rhodes buff 100, 200, 300, 400 each time through the loop. So actually I'm going to do this right here. I'm going to put another underscore right there. And then this buff distance, what data type is that? Is it a string? We have to make it a string because look, it's going to be a number in here. So we have to make that a string. Okay? And then what we also have to do is still, because it's a shapefile, we have to feed it that because we're trying to save into a shapefile workspace. If we were trying to save into a GData space workspace, we wouldn't need that. But since we are trying to save into a shapefile workspace, we need this. Okay, I'm going to make this big. I don't know. Let's try it without it. See what happens. Okay. The other thing I'm going to change is distance field. I don't want it to be distance field anymore. I want it to be this value. So now each time through the loop, the first time it'll be 100, 200, 300, 400, 500, 600. Okay? I'm going to try to run it. I'll go back to it. Actually, I want to see if it's failing. So I should put a print statement in here, ideally. Well, one thing it looks like it's done. All right. So now let's see if it ran. It looks like it did, 100, 200. So it doesn't look like you actually need to tell it to be a shape. By default, it will be a shape. And it also looks like it doesn't include the last 1,000. That makes sense, though. So it just goes 100 to 900. So now I have this pretty rainbow. That looks pretty. There we go. So these are all the individual buffers. So I ran it multiple times and I buffered it out a bunch of times. Okay. I could union all those layers, and then I'd have a multiple buffer, one file with all those buffers in there. You know, but actually there is a tool called multiple ring buffer that does that. Okay, but what's interesting is what's that? Right. But what's interesting, actually, yeah, edit. Look, I'm editing this, and there's some engineers, software engineers at ArcGIS that actually at ESRI, they actually did this. So they're actually running it, and they have a lot of code in here that does more error checking than your code. But basically, they're doing the same thing. Let's see if we can find the loop, the for statement. Yeah. Okay, create multiple buffers. So here's the 4 distance and distances. So they're just using a different, a slightly different way to do it, but they're still running a for statement, and they're still buffering the data, buffer analysis. They're still running a buffer analysis each time through the loop. They're writing all the temporary data to the Scratch database, which the Scratch geodatabase is the same. So you have you have your workspace, and you also have a Scratch workspace. And your Scratch workspace is where you write stuff that you just want to have to be temporary. All right. So we're gonna talk later. We're gonna talk a little bit more about what they did here, which is basically they have run a Python tool from ArcGIS. Anytime that you see this symbol right here, you see this little paper that looks like it's like a ancient scroll, which is like the opposite of ArcGIS, right? But anytime you see that ancient scroll there, it means that there's Python running behind that tool. That tool is using Python. If it just has the little hammer, that means it's running like magical compiled in EXE, like a ArcGIS, probably C++ code that's been compiled to an EXE in it. Yeah, here's a couple. I know that there's a couple inside of the spatial statistics tools. Yep, they're all Python. So you could right-click on them, and you could see that they're just Python. Of course, it's beyond what we're doing right now. This one actually uses a class. See that defines a class. But all right. Okay, so I think that might be where we stop for the break. Let me just see if there's anything else I wanted to mention before we do. I think there is one more thing. So here, I did want to talk about. We'll bring this up a little bit more when we do raster, but we can change the cell size. I talked about the extent. The extent is one that you want to change a lot. By default, if you do an intersect between 2 layers, you're only going to get you're only going to get where they overlap. So sometimes when you're calculating things, you need to make sure you set your extent to be the union of all the layers. Okay. So describe is the last one. By the way, I wanted to point out to you that ArcGIS has actually, I think, pretty good help. So if you type in ArcPy describe, you could usually the first one or the second one. Actually, it's going to be the second one. So this one is the and sometimes they're similar, but this is actually ArcGIS Pro, which is a brand new software, a brand new product. You want to get the ArcMap version of the same thing. So let me type in ArcMap. Yeah, okay, now I'm on ArcMap. They're usually 99% of the time they're the exact same, but we want to make sure that we're getting the help from Describe. Okay, so what Describe is actually a function inside of ArcGIS that will describe a data set for you. And what that does is it returns information about that data set, such as the name of the data set, where it is, if it has any children. But we can look at all of the parameters right here. One of the things that we could do is find out what type of thing it is. Is it a shapefile? Is it a geodatabase? Is it raster? Is it vector? So I'm just gonna run this part real quick. So let's just extend it onto here, and I'll call this 4. file. Actually, what I'm going to do, I'm going to save this. And I'm going to go File. I'm going to open up 2. I'm going to do it inside of 2 because it'll be easier. And I'm just going to describe the output data. First, I'm going to print it. It's not going to be very useful printed. So I'm going to run this, and we're going to see what it prints off. It's going to just say oh, did I leave it open inside of ArcGIS? Yep, I did. It's just going to say ArcGIS describe object. It may give us a little bit more information, but I'm pretty sure, yeah, okay. Geoprocessing describe data object. If we want to get any of the information out of this described data object, we have to actually look at the help and find out what do we want to know. Do we want to know the path? Do we want to know the data type? That sounds like something that would be useful. We might want to know the base name. The base name will be everything without the extension, without the file extension. And then the extension will give us just the extension. But let's say I want to know the data type. Where was that data type? Now, it's not going to say it's not going to say string. It's going to actually tell us the type of data that it is. So this data type is a little different than what we've been calling a data type. So it tells me that that is a shapefile. Okay? So why would that be useful? Well, I might, in ArcGIS, I might ask it to find all of the files in a directory, and then I might want to do something with only the shapefiles in that directory, or only the raster grids in that directory. And so I could use that to build logic. Okay? We might try that in our labs in the future. But that describe object will give us information about a particular. So you feed it a path name, and it tells you, oh, that's a shapefile. In case you didn't know already, that's what it is. All right. I'm going to go ahead and stop there, and then when we come back, we're going to work through the lab, and like I said, what we're going to do is basically talk about how we solve this problem, and we're actually going to solve the entire problem in ArcGIS, and then we're going to start coding it up, but you're going to finish it off. All right, so I'm going to stop the video there, and let's come back at about 10 after 3.